Hello, we are going to be solving a nonlinear system of equations. And in this case, we have a parabola and a line. So here they are. And when it says solve the system, we're looking for the intersection points between those two things. Since it's a parabola and a line, it could be 2 points, 1 point, or no points. So we start by solving either one of these equations for either one of the variables. I just picked what's easiest, which was solving the purple one for x. It doesn't matter what you pick. Now we're substituting y plus 1 in where we see x in the black equation. That's why this is called the substitution method. And now we have one equation with just one variable in it. We know how to solve that. So we're going to be expanding out that y plus 1, combining like terms, and eventually figuring out the y value of the point or points where that parabola and that line intersect. Sometimes people have a hard time with this step. It's factoring out a y or the distributive property going backwards. If you look at the bottom equation and do the distributive property on it, you get the one above it. That's how I think of it, but it's called factoring out the y. All right, so now we set each part equal to 0, just like we usually do for a quadratic. We get y equals 0 and y equals 1. Those are the y values of our points. So it looks like we have 2 points this time where those functions intersect each other. So now we need to figure out what x values go with those, and you need to stay organized when you do this. So I like to just write the point with the y value in the point so that I know what's going on. Then I use either equation, put that y value in one of the equations, find out what x goes with that y. Do the same thing for the other point. And we now know that we have 2 points where they intersect, and we know what both of those points are. And there they are. And we're going to take a look at the graph of this system of equations. In this case, neither one of those cause any problems for us. We're not taking the square root of a negative number or anything like that. So we don't have any extraneous solutions to get rid of. Here's the graph, and you can see that we do have 1, 0 and 2, 1 for the solutions of this set of equations. And I've added on here a slide with the steps to follow when you're doing one of these problems, just to help you work through it. You can take a screenshot of this or just write it down in your notes. And just remember, this is the substitution method that you can use for any system of equations, whether it's linear or nonlinear. Thanks.